Okay, this one's pretty lengthy, so I'm going to read this to you guys just so we're all on the same page here. In 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a newborn baby's health: skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0, 1 to 2 scale to rate a newborn on each of those 5 criteria. A baby's APGAR score is the sum of the ratings on each of the 5 scales. So if you get a 2, because you're perfect, your baby's perfect at all 5 things, it's going to be a maximum of 10. If your baby is real unhealthy and you get a 0 on each one of them, you get an APGAR score of 0. And of course, there's a bunch in between. A baby's APGAR score is the sum of the ratings on those 5 scales, which gives a whole number from 0 to 10 as a value. APGAR scores are still used today to evaluate the health of newborns. Although this procedure was later named for Dr. Apgar, the acronym APGAR also represents the 5 scales: appearance, pulse, grimace, which I guess is response to stimulating. We'll talk about that. What the hell are we doing to these kids? Activity and respiration. What APGAR scores are typical? To find out, researchers recorded the APGAR scores of more than 2 million newborn babies in a single year. Imagine selecting one of those newborns at random, so that's our chance process, and define the random variable x to be the APGAR score of a randomly selected newborn baby 1 minute after they're born. So we check them out on all 5 of these things right away. The table gives the probability distribution for x. Show the probability distribution for x is valid. Now, if you got to show that it's valid, you got to check all of these to make sure that they're between 0 and 1. They are. None of them are negative, and none of them are more than 1. And then you're supposed to add them all up and see if they equal 1. Well, I'm not getting a calculator out for that, especially since it's written right here. Look, add them up, you get 1. Hey! Now, I'm going to go to the second page here, because in the notes I asked you to look at both of these examples. So we're carrying on with the same example here. Refer to the previous example. There's the table. Doctors decided that an APGAR score of 7 or higher indicates a healthy baby. You're less than 7, we got to keep an eye on this kid. What's the probability that a randomly selected baby is healthy? 7 or higher means go to 7, 8, 9, and 10 and add all 4 of these up. So I do want you to pay particular attention to the notation. Do not get lazy. The notation helps. The probability that x is greater than or equal to 7 is these 4 things added together. I'm going to say this word again. They're mutually exclusive, so I'm allowed to just add them together. This is a probability of A or B or C or D using our terminology from last chapter. And you got almost a 91% chance of having a healthy baby. All right, so let's go to the last page of the notes. Definition. A continuous random variable, U-O-U-S, look, I did it right that time, has an infinite number of possible values for x that are represented as any number on an interval from a number line. For example, if I ask you to randomly pick any real number between 0 and 1, you guys know there's an infinite amount of possible things there. They're all trapped between 0 and 1, so I can see where they are, but there are definitely an infinite amount of them. One way to tell between a discrete and a random variable, because you'll be asked to answer for homework, is this a discrete or a continuous random variable? Well, this is just stupid. I'm missing a word there. Discrete and continuous random variables. I did that so I could make sure I spell it right. Discrete random variables are usually the result of counting something, and so they have a limited amount of possibilities, where continuous random variables are usually the result of measuring something. Height, weight, temperatures, example, where the only limitation on like temperature, for example, is how many decimal places do you want to go in order to estimate the temperature. Technically, there's an infinite amount of possibilities. Example. Would the variable in each scenario be discrete random variable or continuous? We'll put the letter D or the letter C for each one. Arm length of a randomly selected student. Okay, it's a length, it's a measurement, so I could just go to inches or half inches or quarter inches, or I could use the metric system and use as many decimals as I want, so that's a continuous random variable. The number of students in this class that will have their homework done tomorrow. I'm not feeling real strong about that. When I'm counting the number of students, that's going to be D for discrete. That is a finite, it's on the other page. That's a countable number of options. because there's only so many kids in the class. The time it takes to get from period 4 to period 5. Well, if we're just talking minutes, that's probably a discrete random variable, but we're measuring something, and if we wanted to go to decimals, we could go as far as we want. There's an infinite amount of possibilities. So this little idea from the author of check to see if you're counting something or measuring something, time is a measurement, that will be continuous. The tension setting on strings for a tennis racket. I'm measuring something again, aren't I? So if I wanted to go a whole bunch of decimals, I could go as many as I want. There's an infinite amount of possibilities. And then the number of penalty flags thrown during the Super Bowl. I'm so dumb. You know what? I'm not even going to fix it. I'm going to live with it. That's how I'm spelling Super Bowl for the rest of my life. The number of flags somebody can throw. We're counting how many penalty flags show up. And so that would be D for discrete. All right, one last example before we're done here for the day. On page 336, making the grade. Go to page 336, and here we go. We are given another discrete random variable because we wrote down all the options. There's a countable number of options. Indiana University Bloomington posts the grade distributions for its courses online. In a recent semester of a business statistics course, there's a whole bunch of percentages for A's, B's, C's, D's, and F's. And so, choose a business statistics student at random. The student's grade on a 4-point scale where A is a 4. So that's an A, that's a B, that's a C, that's a D, and that's an F. Is X a discrete or continuous random variable? I already gave that away. It's discrete because I can count them. Show that the probability distribution is valid. They are all between 0 and 1. None of them are negative. None of them are bigger than 1. And if I add them up, they will end up adding up to 1. The sum will be 1. Explain in words what the probability X is greater than 3 means. Greater than or equal to 3 means the student got an A or a B, doesn't it? B or higher. Write the event the student got a grade worse than C using probability notation. Worse than C is these two, I think, right? So here we go. Hopefully you got your book open. The first one says, is it discrete or continuous? It is discrete. It's discrete because there are 5 options. It's countable, and so it's discrete. This is valid because each probability is 0 is less than or equal to probability is less than or equal to 1, and they add up to 1. I didn't get my calculator out and check, but let's just assume that I did previously. Greater than or equal to 3 means the probability of B or A. And so how do we find that probability? Oh, am I supposed to do that in words? My bad. Here, I'll put it in parentheses. Get an A or B. Okay, the probability that X is equal to greater than or equal to 3. It's the probability that X equals 3 plus the probability that X equals 4. And so I'm going to add up those two probabilities. I go to the chart and I got 0.362. And I'm going to add to that 0.457. And if you add up both of those, you get 0.819. So around 82% of students tend to get A's or B's. Number 4, the last question, write the event the student got a grade worse than C using probability notation. So that's going to go like this. Probability that X is less than 2. That's going to equal the probability that X equals 0 plus the probability that X equals 1. And so that's going to be, looking at the chart here, 0.011. That's probability of failing the class. Plus 0.032, that's a probability of getting a D in the class. It's 0.043, people. Hey, so there's our first day of Chapter 5. Second semester is here. Page 336, here's your big fat homework assignment. 2, 6, 9, 12, and 14. I will post the answers by the end of the day. It's a new semester. You guys stay on top of your stuff. Lots of people fell behind and they all paid for it. Tried to make it up at the end of the semester. Made me work harder, which makes me angry. I'm not giving you that much homework, man. Fill in your notes. Do the homework, check your answers. It's really not that hard. Be a grown-up, you know what I mean? Be a grown-up. Hey, welcome back. I'll see you guys tomorrow.